All right. Good morning, everyone, and welcome to ARE Discussions, a webinar series held on the first Tuesday of each month. ARE Discussions hosts a panel of experts to discuss issues facing California's agricultural and natural resource communities. My name is Tina Saitone, and I'm an Associate Professor of Extension in the Department of Agricultural and Resource Economics at UC Davis. This series is being organized and hosted by the Cooperative Extension Specialists in Ag and Resource Economics across UC campuses. Brittany Goodrich and myself are specialists at UC Davis. Mehdi Namadi is a specialist at UC Riverside, and Ellen Bruno is a specialist at UC Berkeley. A few housekeeping items before we get started. This webinar will run for 1 hour and 15 minutes. Each speaker will be conducted via guided Q&A for about the first 30 minutes for each of them. And then we will reserve some time at the end of the webinar for audience-based questions, which Brittany will lead. All of our webinars are being recorded and will be available on our website, arediscussions.ucdavis.edu. Today's webinar will focus on drought and climate change impacts on urban and rural water users. We have two esteemed panelists to guide our discussion today. The first is Max Auffhammer, who's the George Pardee Professor of International Sustainable Development in the Department of Agricultural and Resource Economics at UC Berkeley. And the second is Kurt Schwabe, a Professor of Environmental Economics and Public Policy in the School of Public Policy at UC Riverside. We'd like to thank you both for joining us. For all of those attendees, we're going to do a short poll before we get started. We're trying to make our webinar a little more focused and guided by our audience participation. And so we want to ask you just a couple questions about yourselves and potential topics for the future before we get into Ellen conducting guided Q&A with Max.
All right, I'm going to go ahead and end the poll and get started here. All right, I'm so excited to have Max here, rope him into ARE discussions. So Max, you're working on a project about weather and climate and how this influences residential water use using a bunch of cool data in California, which sounds really relevant for thinking about the current drought and future droughts. So we'd love to hear a little bit more about the project. Could you start by, well, I guess first telling us who the project's with, and then telling us a bit more about the motivation, like why is it important to sort of study this relationship between residential water use and climate?
All right, first off, thank you, Ellen, and everyone for having me. This is so exciting. I also want to just state up front how excited I am to be part of an extension event. You know, the cooperation within our departments between extension, professors of extension and graduate students and us is so important, and building linkages to the folks who actually do the stuff we study out in the real world is something really exciting for me. So I'm super excited to be here. This is a paper with Mehdi Namadi, who's going to lead the next Q&A, who brings all the technical skill, and Stephen Buck, who's at Kentucky, who brings all of the intellectual firepower. I'm just the one with a good sense of humor here, who's going to try and explain what we're currently doing. The other thing I wanted to say up front, this is very much work in progress. So this is not, we finished the paper and the results are finalized and we're ready to go out and, send these to a journal. We're still working very hard on this, but I think it's sometimes really exciting to talk about stuff that's currently ongoing, share some preliminary findings. And if anybody in the audience would like to talk more, I'm more than happy to follow up by email or phone or one of those many Zoom calls that we all have been on. So why is this important? I've spent basically since the beginning of grad school most of my time trying to figure out how climate change affects economic outcomes. So a lot of my time initially was spent looking at agriculture, specifically rice and the impacts of temperature and rainfall patterns on rice agriculture. Then I spent about 10 years looking at the energy sector, looking at how extreme heat events affect peak load. So think about, the hottest day in California is always the one when we're worried that the lights will go out, because frankly, the air conditioners are what use most of our energy on these hot days. So trying to figure out what happens, how frequent are these are these peak events going to be? Not necessarily outages, that's a sort of choice variable, but the demand is something we're worried about. And in the process of that, started thinking a little bit about what are we using energy for in the great state of California. So we use it to charge our Teslas, our electric bikes, our iPhones, keep the lights on. But one major use of energy in California is our water infrastructure. So we are a dry place in the semi-arid West. I don't know why we call it semi. Maybe we should drop the semi from the West, from that word. It's very dry. I haven't seen a raindrop in close to a year here. And we spent a lot of energy shipping water around the states, both vertically pulling it up, as well as shipping it horizontally and across mountain ranges and stuff like that. So in academia, there were always these grant proposals that were looking for the mythical water energy nexus. And there were lots of hypotheses about how the water and the energy economy intersect. And I was trying to think about how would you actually go about measuring that in a climate change context? So we all know that, I think this number is still right, roughly 80% of water in California goes to agricultural type uses. So if we're thinking about what's left over for residential users, it's somewhere in the neighborhood of 10-ish%, give or take a couple. But there's a lot of attention being paid to those end uses, right? We all know our low flow toilets, we're encouraged to put in drip irrigation and real-time water meters in our homes. So that's all trying to pressure us to conserve water, which is a good thing, right? As the economist, I'd like to remind all of us that we're getting a tremendous amount of value out of the water we use, right? Washing your face, if you're not a teenager, is a beautiful thing. Drinking a glass of water, you get lots of consumer surplus. But, most of the, especially in single family residences, most of the water we use doesn't go on the inside of the house, it goes on the outside of the house, right? So if I look around my yard, we've killed most of the lawn, but there's a little lawn left. We're growing delicious tomatoes. There's a lot of irrigation water that goes on there. So the question I'm interested in is not just how is climate regulation going to affect the energy and the water economy, but how is the actual physical climate change going to change consumption patterns? So if it gets hotter outside and then you see your yard dying a slow and painful death outside your house, are you going to reprogram your little device at the side of your house that says, I'm going to add an extra 10 minutes to the front yard, an extra 10 minutes to the backyard to make sure my roses bloom and my lawn doesn't look brown? So again, I'm not making value judgments here. I'm just trying to say, generally speaking, what do single family residences with the means to actually water their yards do when it gets hotter? The hypothesis is they're going to apply more water to their front lawns. So why climate change? I think you can see the connection pretty straightforward. If it's hotter outside and we get less precipitation, right? You have a couple of choices. You can, I believe it's called xeriscape. They're the desert plants out in your front yard that use less water, or you apply more water, or you let your yard die. So what when I say I mean we, sorry, Mehdi, Steve, and I were thinking about here is, can we measure the relationship between residential water demand and temperature and figure out what part of this, without actually knowing internal household metering, is due to outside watering demand, and then simulate out what happens to water demand if the climate gets warmer and there's less precipitation. So the ultimate goal here is sort of twofold. One, figure out what happens to residential water demand as it gets warmer out to the end of the century. And B, and this is going to be a bit of a back of the envelope ex post calculation here, but that looks at how much energy is actually embedded in the gallon of water you're currently applying to your tomatoes in the backyard, right? Did we use any energy to get the water to you? The answer is in most places, yes. And it's not the same amount of energy. There's a lot of heterogeneity depending on where you are, how much embedded water there is in your energy. So we'll figure out what happens to residential, we'll figure out projections for residential water demand, but at the same time thinking about, is there, I call it the electrons on the lawn. Are we sprinkling not just H2O molecules on the lawn, but are we implicitly also sprinkling some electrons on the lawn here? Not physically, but the embedded ones that got the water there, to sort of quantify what you could think of as an energy penalty of residential irrigation demand. Last but not least, so you asked me, why is this important? I don't think I need to stress this to this audience. I saw that 85% of the people on this call are somewhere in California. I assume very few of them are in the far north, where it's maybe not quite as bad as in the far south. But we've been living through a historic drought. Climate change is not going to make this better. So trying to figure out what we're going to have to do to manage our residential water demand, and I'm just taking ag water demand as given here for now. I'm going to bracket that out. I'm just looking at residential, right? That's a whole different set of policy questions, but looking at how that's going to affect our difficulty in reducing water demand and energy demand, because while we're trying to mitigate, climate change itself is going to keep on pushing the baseline up. So that's sort of where we're at this point and why we're doing this.
Cool. Yeah, that's great. Thanks, Max. So obviously, to start to get at this relationship between temperature and residential water consumption patterns, you're going to need some data. So were you able to get data on residential water use, indoor, outdoor? What does it look like for this project? So if anybody has better data, I really want to hear from you. I'll put my cell phone number in the chat in a minute, and then you can call me and say, I have much better data. So I was a little spoiled. I'm a research associate at the Energy Institute here at UC Berkeley, and we have a very friendly relationship with California's investor-owned and municipal utilities, who often share household level, anonymized, and we treat it just right. It's in a dark room with no connection to the internet, so Kurt's electricity bill is safe. But the basic notion is we, for electricity users, have a huge amount of detail on bill level consumption, and in some settings from smart meter consumption, knowing exactly how much electricity you use at sort of a 15-second, 30-second, or 5-minute interval in different settings. Water is a little bit behind, right? The number of water utilities that actually have smart meters out there is still, for all of their customers, is still relatively small, even though that's starting to increase. I personally just installed a flume on my water meter, really cool. So I have high frequency water consumption in my house, and I now yell at my son when he's in the shower for too long, and he yells at me when I irrigate my tomatoes. So, source of conflict. But the question you asked, do we have amazing data like this for this study? And the answer is we wish. So what we do have is, for a large number of water retailers in California, we have monthly average consumption by household type. So think about
one observation for a water retailer for single family residences. So I know on average for Kurt's water retailer, what the average household for Kurt's water retailer consumed in June of 2019. Is that as good as knowing what Kurt and all of his neighbors and his neighbors' neighbors and his neighbors' neighbors consume? No, right? But it's a first step. The reason we like this one is we have it for a large number of retailers across the state. So this is not just a small part of Southern California or the Bay Area or the East Bay or something like that. It actually spans most of the state. So we get lots of variation in the climates and types of houses that are in these places. And we also have it for a relatively long period of time, which varies across retailer. For some retailers, we have it for over 10 years. For other retailers, we have it for a little bit shorter. But that's the water data. On the weather side, there's a huge number of weather data products you can use. Here, we're going to use a product from our friends up at Oregon State University, who have a project called Prism, like the thing you show your kid that, you know, puts the light into its individual ingredients, that have at a grid scale level historical temperature for the entire United States, the lower 48, on a daily level. So you observe daily minimum, daily maximum, and average temperature. So we map that to the individual water retailers. We know where they are and we know what their boundaries are. So we, in some sense, have daily temperature and some measure of variation for the individual water retailers. We have the same thing for precipitation. And then, so that's history. And then for the future, trying to figure out what does future climate look like. We currently are still working with CMIP 5, which is the last IPCC assessment reports, downscaled climate models. There's now a data product out for the most recent climate report from the IPCC, CMIP 6, but we don't have the downscaled version because we're dealing with really sort of disaggregated regions in California. So a grid box, an average future weather that's the size of Northern California doesn't really help me here. So we're working on that, but they're essentially, you can think of 20 different climate models that each simulate different versions of the future in terms of temperature and rainfall out until 2100. So pretty fun data, but the water data is still not as good as the electricity data, but it's a first step.
Yeah, great. Okay, well, I'm dying to know what you found, but before getting there, could you tell us just a little bit of how you analyze the data at sort of a high level? Yeah.
So this is this is what I could talk about for a long time, and I'm not going to. So I see my department chairs on the call, so I better behave. But the basic notion here is we're going to use statistical methods, econometric methods, to run regression models that, as an outcome, have water consumption in a given month for a given water retailer. And on the right-hand side of the equation, we have really flexible measures of weather. So don't think average temperature in a month, but we're actually going to be able to see how does water consumption change if it gets 5 degrees warmer on a 70 to 75 degree day versus a 60 to 65 degree day, right? Similar to the way we think about air conditioning, electricity consumption goes up much more if it's 5 degree warmers when it's already 80 degrees out than if it's 60, 65 degrees and it gets 5 degree warmer. So a really flexible regression model. What this does not have in it, I was taught in graduate school, admit to your sins and admit to your sins early. Adaptation is a big question in this particular field, right? So if I asked you, Ellen, predict what California's water infrastructure is going to look like by 2100, you could probably tell some stories about probably some more storage here and there, and technology is going to change. But imagine putting yourself back in sort of 1920 and predicting what 2000's energy economy was going to look like. Could we have predicted the electrical grid? Could we have predicted the state and federal water projects and things like that? So it's hard to figure out what the physical water infrastructure and the institutions to support it, and property rights, frankly, are going to look like by end of century. If we have, and I'm going to use that property rights word, which usually makes people shudder a little bit, but imagine this drought going on another decade, right? Are regulators going to continue, standing by the current property rights regime in California, or are we as a society going to question it? Again, I'm not saying we should. I'm just saying in times of crisis, we often question current regimes, so we don't know what the future is going to look like. So what these projections do is they essentially assume that you're using whatever irrigation technology you've got currently. Kurt, sorry, I keep on picking on Kurt. Kurt and Mehdi don't get to plan a cacti instead of their lawns right now, but we're just trying to see if current technology is in place, how much more water is going to end up on our lawns. And it tells us sort of the upper bound in some sense of what the increase in water demand is going to be if they then install high efficiency drip irrigation, if water becomes more expensive, if we plant less water demanding plants, that the impacts are going to be less, but it gives us a baseline given current technology, right? So this is not a forecast. This is a scenario assuming current technology going forward.
Right, that makes sense. All right, so tell us, what are you finding so far in terms of how water consumption responds to changes in temperature?
So it's super fun, right? In these projects, you spent sort of 10, 12 months organizing data and looking for weird outliers and asking questions. Why does this observation look weird? And then squeezing, it sounds like I call my friends in Oregon and I have weather data at the daily level for a water retailer. Doing this, anybody who's done this, is a huge pain in the neck, and it takes a long time. So we've put the data together, we've run some regressions, and what we've found, I thought was kind of interesting. So if you look at the winter months, and we haven't looked at underlying heterogeneity yet, Southern versus Northern California, which might be different, but what makes sense to me is what we're seeing is at low temperatures, we're seeing very little response of water demand to temperatures. But as you get up into the 70, 75 degree range of average daily temperature, you see a pretty significant uptick in water demand. And as it gets hot, it just keeps on going up. So what we're seeing here is folks on this call are probably going to say, duh, it gets hotter outside. People use more water in the summer. We see that in the data, measurable, and we have point estimates with confidence intervals around them that show us measures of statistical uncertainty of how much that goes up by the average household. If we look at winter months, that relationship is still there, but it's much flatter. So the why that would be, to me, is pretty straightforward. When I used to have a dumb water irrigation system, like one of the ones where you actually had to go up and you have to set the clock and you have to look for your manual about which one of the bleached buttons you have to push to turn it on and off and set the different zones in your yard. I used to go out there in the winter at the first rainfall and I just turned the irrigation off. And then in the springtime, when it got a little bit drier outside and it hasn't rained in a couple of weeks and I see my plants dying, I turned it back on. And that's how I manage my irrigation. Now I have a smart thing. Imagine a Nest or an Ecobee for your irrigation. It's called Ratio. There are other products out there too, where from my phone, I can control irrigation in my yard. And it now does what I used to do, right? So if it sees rain or it sees the season changes, it knows what plants are in my yard and it turns off zones when they don't need water. So we should expect a lower temperature response of water in the wintertime than in the summertime, and that's exactly what we're seeing, which is pretty exciting. We're going to look a little bit at heterogeneity. Is this different in Southern California versus Northern California? But the data sort of back up what we thought we'd find.
Cool. So what does this imply if we want to think about climate change? What can we extrapolate from this about future water use under climate change?
So since we're, 79 close friends on this call, I'm going to trust that this is not ready to be written down in a newspaper. This is a ballpark estimate, so please don't cite this number out there. And even worse, make policy based on it. For the policymakers on the call, when we have a working paper that we're feeling fully confident in and that has been quadruple checked, we will send it to you gladly. I will bring it to you and explain it to you if you want. But right now, looks similar to what we're seeing in electricity consumption. We're seeing maybe by end of century about a 10% increase in residential water consumption from climate change, which isn't small, but it's also not huge. If you're thinking about the sort of turn this into an annual growth figure, that's not a doubling by end of century or anything drastic like that, but it is 10% increase. And any policymaker that's been trying to push any outcome you can think of down by 10%, that's really hard to do. So if you've got another 10% to work against, it makes picking the right measures trickier. In terms of energy consumption, that one varies. So what you have to do here is a weighted average, which for some reason we've I think stopped teaching in high school. We need to do this again, because every time I say weighted average in my class, I get the big staring eyes. What is that? But we have to think a little bit about energy consumption, because if your water is pumped across a mountain range, there's lots more energy in it than if your water was just came down the side of a hillside straight into your yard, essentially. So we have to take care of that. So the energy figure might actually be a little bit bigger than the 10%, but it's not going to be wildly bigger than 10%.
Great. So keeping in mind, of course, that this is work in progress, I'm curious if you have thought about sort of any specific policy implications of the work, or if not, if you have any sort of concluding remarks about this work and where you're going next.
So, the way academics think about policy and the way that policymakers think about policy, unfortunately, is always very different. We have this, sort of idealized version of how policy is made and often ignore the political and political economy constraints within the, that policymakers face on a day-to-day basis. But I think what this just shines a light on, and it's something that CPUC and CEC have thought about, right? There's projects on this, trying to think about what's the linkage between sort of energy saving measures and water conservation measures. What this project does is it's a way to help us think about what that link is in the context of climate change for a small sector that affects, how many of us are there? 30-some million people in California at this point. Affects a lot of people, creates a lot of consumer surplus and welfare. So it helps us think a little bit about, how big and important is that nexus for residential users? What does this mean in terms of climate change, in terms of an order of magnitude of how much more we have to do, because demand for water is going to go up because of what we're trying to deal with here. And it also, to me, stresses the fact that too few folks in my personal field have historically worked on water. So some of the rock stars, you are one of them, working on water economics and how we manage this precious resource in the state of California, but elsewhere as well. I think it's time for folks to switch back into this important field, especially now that data are becoming better, and study these important issues. Because to me, water is the issue in the context of climate change if we're thinking about California. We're thinking a lot about energy and electricity markets and renewables and cap and trade. These are all very important issues. But I think if we don't take seriously the water challenge that we face here and put some welfare numbers on it, which is what economists are good at, we're not doing our job as economists. So this was an exciting project to work on. Most exciting part was working with two, all-stars. Mehdi and Steve are both just wonderful economists. And once we finished this up, we're going to share this paper with you and anybody on this call who would like it.
Awesome. Thank you, Max. That was great. I want everyone to know I didn't pay him to say those words at the end about water economics. So great. Thanks so much for sharing that work. And I'll pass it off to Mehdi now.
Thanks, Max and Ellen, for a great discussion. And next we have Kurt Schwabe from UCR School of Public Policy. He works on various impacts of droughts or current impacts of droughts on affordability, on health, and on wastewater treatment plants. And he's going to share some of that today with us. Kurt, would you mind telling us a little bit about droughts in California, the history, and everything that you think is interesting about it?
Yeah, I probably want to thank, and first of all, thanks for inviting me. It's great to be part of this panel and this this talk, and thanks for organizing this throughout the year. I look forward to listening to some other really excellent talks. I use the old system that Max was discussing. I'm not sure if that's because I'm the operator, the dumb operator, but I still go out and turn it off and on. But I've got to upgrade my game on this, I guess. Yeah, I won't go into the history so much of droughts. If people want to know, I can certainly send them references. But just kind of the current drought, it's interesting, and I'll share my screen and go over a few slides on that if that's okay. Let's see if I can do this. All right, I can do this better than my irrigation controller. There we go. So just and I know I won't spend much time on this because I know that we all most of us are from California, or it's been in the news quite a bit. But here's some two slides from NOAA and in 2021. The left slide's from 1900 to 2020. The right and same with the right slide. Basically, the issue is that it's bad, the current drought. And if you see the dots are the 20-month average millimeters of precipitation relative throughout the 1900s, and the line is the 20-year average. And you can see it on the left graph, just that dot goes pretty far down, and on the right graph, the dots go pretty far up, and therefore, less precipitation, and it's a hotter environment. And this has led to, it being the third hottest on record, spring on record, and the lowest precipitation. And in California, it's certainly the hottest on record, the hottest spring on record. Mike Dettinger from Scripps and working with the PPIC said I could use this slide here. And it gets at this idea that Max was talking about, there's lower precipitation, but there's also increase in evapotranspiration, heat, solar radiation, wind, etc. And he kind of says, let's break this up, this current drought, into both changes in precipitation, but also the heat effect. So the first slide is kind of this idea of, how has precipitation changed to contribute to the drought? And we see that certainly in Northern California, there's a lot less precipitation, negative DP, than from, I think it's 1980 to 2020 or 10 is his baseline reference point. But this is from October 2019 to 2021. The next slide is net ETO. So it's, to some extent, if you water a grass with regular, during regular times with the amount of precipitation need, under this current drought with the increase in ETO, evapotranspiration, how much of a deficit are we in? And in that sense, you see that, again, the Central Valley, a little bit Northern California, you see the greater ET surplus, meaning ET is above and beyond what we typically would need to water our lawns and such. And then when you put them together, you get kind of the whole impact of the drought forcing on California. And right now you see this last one is the fraction of the overall drought forcing this precipitation. So you don't see it being all red or yellow. And what that means is that in some places the drought is mostly precipitation based, but in other areas it's really less precipitation based, and there's a huge component, up to 67% of the precipitation drought is from increases in ET and heat, essentially. Now, what's just interesting is if you look at the precipitation we're going through right now, it's actually, there was less precipitation in 1977 during our 77-78 drought, but the runoff is about the same because of the increase in heat and ET. Just I'm not going to spend much time on this, but our reservoir levels throughout the state are not in great conditions right now. Basically, if you look at the top left corner, you see the state reservoirs throughout the state. The one that looks to be pretty good is in Southern California, Lake Paris, which is about a stone's throw away from me. They're doing pretty good down there. And it kind of starts to get to this idea of what's going on in Southern California that's not happening in the rest of the state. And if you move to the right, you see what's going on is, since 1990, Southern California has doubled its surface reservoir storage. And one thing it did was, since the 1990 drought, it built Diamond Valley Lake, which is about 850,000 acre feet capacity there. And so it went into Southern California Metropolitan Water District, went into 2021 with historic surpluses in its reservoirs. And in that sense, it's made these huge investments, and it's saying, well, we still have a lot of surplus, and so maybe we don't need to ask people to create these mandates for people to reduce usage. So the bottom right corner is metropolitan storage levels over the last decade, and you can see how well they're doing going into 2021. The state's obviously responding. You all are probably familiar with the governor's voluntary request of 15%. Overall, in July, we had a 1.8% reduction. SoCal dropped by about 0.1%, although in LA and San Diego, there was a slight uptick. And to some extent, it was based on all these other programs and water portfolios that they've, to some extent, developed over the last 20 years. There's a drought emergency in 50 to 58 counties. The governor just signed a $15 billion budget package to deal with drought, climate change, and wildfires. The feds declared the first ever water shortage on Colorado. So next year, Mexico, Arizona, and Nevada will all have to take some cuts off the Colorado. If it goes into tier 2, then California must start taking cuts. But all the local agencies, and water is really a local issue, all the local agencies are kind of moving through their own drought contingency plans. And the last thing I want to say is, there are these meteorological droughts that you see often with nidus and such. But because California, we got all this surface storage. We don't have much rain down here, but we've developed a huge water portfolio. It's more of kind of a hydrologic drought that you're really concerned with in terms of its impact on us. So I'll stop right there, Mehdi.
Thanks, Kurt. That's pretty scary. So what I know you do some research on water affordability. What do you find in terms of potential impacts of droughts and water policies in California on water affordability moving forward?
Sure. Yeah, it's a big issue right now. I think of a lot of the water economists, in the 1990s and early 2000s, focused on kind of water conservation and rationing water through prices and comparing prices to non-price instruments and such. I think the game in town now is to look at, how do you deal with water affordability? So there's this efficiency element, and then there's the equity element, and a lot of attention's on affordability, and for good reason. There's been a 45% increase in water costs in California between 2007 and 2015. For those households that are low-income households, their incomes is essentially stagnated or went down a bit. And so if you think about kind of water affordability as, the amount I spend on water over my income, this is a common term people use, it's gone up, right? The fraction of income that I spend on water has gone up, as well as in California. Ask any student right now about housing costs. And so this term that doesn't get a lot of play right now is called discretionary income. So people use these broad categories of income from census tract, which is often the only thing that we can get at really easily right now. But discretionary income is really what we're concerned with. It's the amount of income we have, less water cost, less the cost for other essential needs. So it's what we have at the end of the month, right after we pay all of our other bills. And in some cases, people that are going into debt, that discretionary income is negative. So water costs are rising, and listening to what Max was talking about, it's only going to rise in the future, given that we need to upgrade our infrastructure that's often outdated, and to more buffer ourselves and build in resilience for climate change. Discretionary income right now, it's been stagnant for over 13 million low-income households in California. So what we did was we wanted to kind of just first of all get an idea of the extent of the problem, and we started out with California. There's a state response associated with it. So to wrap this up shortly, is that California is considering a LARA program, a low-income rate assistance program that they already have in the electricity sector, but it's considering it for the public water agencies. The private water agencies already have it regulated through the CPUC, but the public agencies are now considering a LARA system. So the main bills there was AB 401 in 2015, was a bill that was passed to say, let's look at this problem. What do we need to develop a LARA system for public agencies in California? And now SB 22 hasn't been passed yet. It's been passed in the Senate. In the Assembly, they're thinking about what are the real characteristics of this bill if we want to implement it. And one of the interesting differences between AB 401 and AB 222 is they've added wastewater. So wastewater is typically part of everyone's water bill. So you just don't want to look at water, your water costs. You want to look at your total water bill, which services, which include water and wastewater. So anyways, this is likely to increase over time. So we look into this. I won't go into the details right now. We look into it, looking at, what do we mean by affordability? How does affordability or expenditures look across time and across water districts? What are more objective outcomes of affordability? Because there's a lot of different definitions. It's like defining a planet or a continent. And so in this sense, one of the interesting things to do would be to look at how delinquency is explained by different measures of affordability. And at least from an academic perspective, that would be kind of fun to do as well. And then look at the characteristics of households that have less affordable water and maybe higher delinquency rates and such. So we do this for one district right now. We look at measuring what's called our water expenditure ratios. They're water expenditure for different types of water. Is it indoor water? Is it basic needs water? Is it outdoor water? Is it budget-based water? And we divide it over the median household income at the census tract level. And we look at how these things change. Here's an interesting one. So if we think about basic needs water, and let's define that as 36 gallons per capita per day. And what we do there is we say, what is the affordability or the expenditure ratio for all these households in one district? And there's some groups that say, like the UN and EPA suggest that kind of affordable water is measured at about 4.5% of income. It's somewhat an arbitrary number because it depends on what's in the denominator. Anyways, we show that, if you look at essential use water, there's about 4 or 5 households out of 95,000 households in our district that would be above that threshold for, water and sewage services. Anyways, there's a lot of variability there. The key is that water is a local issue, as is the cost of providing water. We're expanding this out to 95 agencies now. Income matters. How you define income really is going to matter in terms of, what your affordability measure is. So if you do read things about affordability, just be a little bit skeptical and look at what they have in the numerator and what they have in the denominator. It's really tough to get accurate numbers for these. But anyways, the state's considering this. There's a lot of considerations associated with affordability that we can talk about later in terms of efficiency, equity, eligibility, enrollment. Typically, these programs are significantly under-enrolled, and then the financial reliability of the district as well. I guess I'll leave it at that.
Thanks, Kurt. That's pretty interesting. And part of your research, and you mentioned a little bit about this, looks at wastewater treatment plants and how state water policies and droughts are affecting these wastewater treatment plants that local agencies made a lot of investment in. Can you tell us a little bit about that and moving forward?
Sure, yeah. And, kind of the idea, what originally kind of caught me was I was at a water meeting and someone said, look, we've got some recycling going on and we know that it never stops raining at a wastewater treatment plant. And I got to thinking about that. I said, wait a second, where does the water come from that goes to a wastewater treatment plant? And then as I started talking to more engineers and such, I saw it's mostly from indoor water use. And as indoor water use decreases, the salinity and the concentrations go up. So maybe it doesn't stop raining, but it goes from maybe a downpour to a drizzle and the quality starts to get a lot worse. So that's what kind of started motivating my thoughts on that. And this is important in California is because we're making significant investments in reducing demand and augmenting supply. And so you see these turf replacement programs, these smart meters, these flume meters, there's subsidies for these things. So while that's going on, water use per capita is going down. People are reducing their indoor water use. They're reducing their outdoor water use. Yay for that part. And then there's these significant investments in recycling wastewater. And if you think about where that wastewater goes, right, a lot of it goes into streams. And in Southern California, there's a number of streams that are effluent dominated. So if you start reducing effluents into streams, you're going to have these ecosystem damages. And then some goes to replenish groundwater and such. So that's kind of that mix. And so, here's just a graph showing how per capita water use has gone down in California over time. And kind of my argument that, we're spending a lot of money investing in reducing consumption, and improving water use efficiency, which we should be doing. And in Southern California, water use now is 20% lower than it was in the 60s, even though population is 30% higher. So, in that sense, this is good. On the same token, we're making significant investments, and we want to make more investments in recycling water. So, metropolitan water districts and LADWP are all investing largely in these regional recycling plants. It's going to take all the wastewater and recycle it and put it into groundwater. And so it's kind of like, is there some conflict between these two? They're both part of a drought resilient portfolio, and we should be investing in these things. I guess my question is, are there unintended consequences? And this isn't just happening in the US, it's happening, or in California, it's happening throughout the US. So kind of, is there this paradox that we started thinking of? Are supposedly efficient actions in one area of what portfolio leading to inefficiencies in another area of the portfolio? And how has policy exacerbated this? And there's my question again. So again, if I'm looking at that figure there, so you have 3 different households. One engages in outdoor conservation, one engages in indoor, and one engages in nothing. Does it have an impact on overall water use and recycling? And we see that, if you engage in a lot of indoor water use conservation, there's just going to be less water to recycle. Right? And for those of you that don't know it, I live in Riverside. And Mehdi used to live here, and now he lives in Orange County. So Mehdi gets my wastewater, actually, and my wastewater gets pumped into the ground down there in the groundwater replenishment system and ends up providing water for 200,000 households. So whereas we get their air quality, their poor air quality, which we can't do much with, they get our poor water, but they actually turn it into a really valuable resource, and I'm still having a hard time letting that one go. Anyway, so we do some research on this, and we look at the effects of the drought mandate, the conservation request during the last drought that we had. We find that the conservation policies led to a negative impact on effluent flows. It's kind of what we hypothesized. So the conservation mandate led to about a 9% reduction in effluent flows, ranging 4 to 16%. It led to an increase in the salinity of the effluent water. And this isn't to say that these aren't important things that should be part of our portfolio, right? But they can have unintended consequences, and we think that policy should be informed about this to make the right decisions. And that was kind of the end, the byline, or the last kind of thing is, you just got to be aware of these consequences to make informed decisions. And the second thing we did was we said, okay, we can't do a lot about the quantity of water that's decreasing, but we can change how the water comes out of the treatment plant and where it goes to, the produced water. So we developed a production model, a process model, looking at different processes to deal with wastewater that has higher concentrations of salinity and other elements. And how do you cost effectively deal with that poor quality wastewater, whether it's going to be used for industrial use, irrigation use, creek discharge, or groundwater discharge, and we come up with cost-effective treatment strategies for that.
Thanks, Garrett. And finally, getting back to Max's presentation about climate change and increased temperatures. You have been working on temperature or increased temperature effects on California health, right? Or Californians' health. Can you tell us a little bit more about that as well?
Yeah, sure. This is a project that started, I was going up through the Central Valley during the drought, and I'd heard about this wonderful work at UC Davis, looking at the impacts of the drought on California. And there was this, $2 billion number that was kind of floating around, which, seems big to the rest of the country, but for California, 2 billion is about 2 or 3% of ag GDP, which is about 2 to 3% of the statewide GDP. And so in one sense, you might think this wasn't such a bad impact, right? In terms of how we dealt with the last drought. And, but, when you go up to the Central Valley, and I started seeing, talking to some of the extension agents that are working up there, and some of the social services personnel and staff at in the county, you start seeing that there was some real pain up in some of these areas in terms of dealing with the drought. And in that sense, it got me thinking about kind of the distribution of impacts of drought. And, economists are good at looking at averages and maybe aggregates, but it's the tails of the distribution that, we're starting to be more cognizant of. And I think the rest of society is as well. How this relates here is in water policy was, I was wondering, is there a role for water policy in affecting the impacts of drought on people, on their well-being and health? There's plenty of work out there looking at the impacts of, say, drought on, say, juvenile fish populations in the Delta, on crop yields, and on, say, watering in Beverly Hills. But I didn't find a lot at that point in time of research looking at the impacts directly on health. And so as you do a little bit more research, you see that there's some great work done up at UC Davis and Berkeley on impact of say, extreme weather events on infants, on suicides, on elderly mortality. And we wanted to look at this in a little more detail, a little bit more granular level, and then look at, does it relate to agricultural communities perhaps, and how does water policy play a role in this? Do areas with more secure water rights, are they able to mitigate those impacts more than, say, areas with less secure rights? So we, I won't go into a lot of the detail here. We collect a lot of data from the California Health Interview Survey, from the Office of Statewide Health Planning and Development, over 11 million birth weights from 1991 to 2011. We have psychological distress from the California Health Survey, 350,000 observations there. We use this network to come up with daily measures for weather, for climate and weather, maximum and minimum temperatures. We come up with definitions for extreme heat, for heat waves and such. And then we look at, I won't go into econometrics there, control for a lot of other factors in terms of mothers, fathers, age, education, whether they have access to medical care, things like that. And basically what we do is you just look at the right side. The left side is just a graph looking at kind of our parameter estimates with 95% confidence intervals over them. But what we find is that hot days reduce birth weights and lead to greater fetal deaths. Hot days shorten gestation as well. The results are strongest when exposure occurs in unseasonably warm or cold periods. And so I don't forget, the majority of this research was done by Maithili Ramachandran. So while I got this, there's a bunch of PIs on this. Our research associate, she did just an amazing job. As Max was saying, getting this stuff together and doing the analysis is a heavy, heavy lift. And Maithili did an amazing job on that. And what her results also showed is that it's more robust impacts occur if experienced in the second trimester of pregnancy. And then we also found greater impacts in agricultural areas. And we're still working on this, but we've got some initial results that aren't very strong. And I think it's about how water allocations may mitigate that. It's just, I don't think we have a good measure of water allocations. We use CVP allocations over time. And, a water district in the Central Valley often has a portfolio of options to deal with water shortages and such. And then we also have some impacts on psychological distress. And basically what we find is nighttime heat waves matter. And it's not necessarily single days that matter to psychological stress, at least our findings. It's the nighttime heat waves. Daytime heat waves don't seem to really have a strong effect. And so this was something that was, you kind of think of nighttime heat waves likely impact sleep, and maybe that's the mechanism. So we haven't gone in depth in terms of the mechanisms yet. That would be the next stage of the research. And there's future extensions there, but I'll stop there because I think we're running out of time.
Perfect. Thanks, Kurt. Do you have any concluding remarks before we open it up for a Q&A with the audience?
Yeah, I love these two quotes. I'll just, there's one difference between a good economist and a bad economist. The bad economist confines himself or herself, they self to the visible effect. The good economist takes into account both the effect that can be seen and the effects that should be foreseen. And that was Frederick Bastiat, a French economist. The other one is from a great movie for Chinatown for anyone that's interested in water in California. Anyways, yeah. So, thanks, nothing to add. But thanks.
Yeah, thanks, Kurt. I pass it on to Brittany to ask the Q&A from the audience.
Yeah, thanks, Mehdi. And thanks, Kurt and Max. There's been a lot of interesting things brought up today. So we're going to go ahead and start off with a couple of questions for Max. But just in case anybody else has any questions that they want answered, please use the Q&A box at the bottom right, and you can enter the questions, and then we'll ask Kurt or Max. So Max, the first one is sort of a two-part question. So does residential water use really matter in the big scheme of water availability? So the person said return flows are very high compared to low-hanging center pivot irrigation, which as a non-water economist, I don't know what return flows are. So please explain that. And then have you thought about when people will stop irrigating altogether and how this would affect your analysis?
So, this is the age-old question, right? What's the highest value use of an acre foot of water? And lots of folks on this call have A, strong opinions, and B, much more experience than I do. So when it comes to being the decider as to who should get which acre foot of water, you know, that's a decision that, you know, we as a society have to decide upon. The way this discussion is run is often, you know, the person with the almonds says almonds is the biggest use. The consumers in urban areas are like, well, consumers are the highest values. It's always like my use is the highest value use. I mean, there are ways of actually figuring this out, right? There are econometric techniques and statistical techniques that sort of let you figure out what the value of an additional acre foot of water is in different contexts. So Steve Buck, Dave Sunding, and I have a paper that tried to figure this out using housing values, or not housing values, the value of vacant lands a long time ago. That's a really nice paper, and again reflects the fact that Steve is a really smart person. So as the economist, you know, we have to think about the bigger picture. We have to think about A, what's the private use of this stuff, but we also have to think a little bit about, or a lot about, what's the social use of this stuff. So if there are externalities involved in this particular setting, then, you know, you should take those into account when you make decisions. There's, you know, questions as to what happens when you put water in the ground in urban settings. Where does it go? It depends very much on what the surface looks like in your particular neighborhood. And Kurt's maybe even, you know, Kurt is definitely much more qualified to talk about this in detail. But, you know, does this stuff just, if you're over the cliffs in La Jolla, does it just run off and straight into the ocean? And it's you know, my $6 million home that's got a beautifully irrigated yard. I'm basically just letting that water run out into the Pacific. Or are there ways to, you know, recover some of that water so Kurt's wastewater ends up in Mehdi's yard? I'm waffling a little bit intentionally because I don't think there really is a good answer to this question, right? Is the value of somebody's yard comparable to the value of, you know, a tree's worth of citrus, or, you know, some almonds or something like that? So you really have to think about the relative value of these activities. When we talk to urban water users and you talk about restrictions to use, people get worked up pretty quickly, right? Water bills are high, especially where I live right here. And it turns into a political issue very quickly. There's a beautiful paper coming out soon by one of our job market candidates, James Sears, who's on the market this year, in case you're trying to hire a brilliant young water economist, who sort of looks at different methods of affecting water consumption by, you know, publicly naming super users, so essentially shaming them, moral suasion, sort of nudging them and saying you have to do better, or using price methods in a really cool natural experiment. So to answer your question head on, I'm not going to answer whether agricultural use or urban use is more valuable. That really depends on a number of questions, but I would argue that efficiency in both places is going to help the semi-arid economy quite a bit if it's done in a cost-effective manner. So I think I haven't lost my environmental economics card yet. Kurt's smiling and Ellen's smiling, so I think I'm still good.
Yeah, Kurt, do you have anything that you want to add to that?
No, no. I mean, I interpret the question that maybe, you know, if urban use is a smaller fraction of overall, you know, use in my little district, if I decide to engage in some efficiency improvements, is that going to make one iota of a difference in the overall scheme of things? Well, remember, water's local, right? And people have their own water rights locally. So it may not make an impact on the delta to some extent if it's local, but it could make an impact to the rates that customers pay, depending on if they've got to invest in other infrastructure because they're using too much water and there are other confronting shortages. So in that sense, from a local perspective, it can make a big difference, perhaps on the affordability side and on the reliability side.
All right, thanks, Kurt. Okay, so we'll ask another question to Kurt. This one is, So the person wrote, it seems like there's an abundance of small water systems that makes it harder to reduce costs to consumers who are often low-income communities. So is there any way to help small water systems take advantage of economies of scale and operating costs?
Yeah, I mean, if you look at some of the research by the PPIC, a lot of costs that are incurred or by agencies are local in that sense. It's the state's contribution to the overall expenditures that agencies confront over the in California is, I think, less than 10%. So if you're going to have an upgrade, typically it's going to be on your own dime. And that's so then you do run into these kind of economies of scale in a sense. And I think one of the things the state is investigating, and I know a number of the water agencies are looking at, is consolidation. So you might get like a smaller town like East Porterville, which had a really significant problem with its access to groundwater, which went below its well during the last drought. And then it's next to Porterville. In that sense, a larger agency can spread out its fixed costs over a larger number of people. And keep in mind, in water, 80% of the costs are fixed costs, or 85%, whereas in the electricity industry, I think it's just flipped, but Max can correct me on that one. So in that sense, your fixed costs are huge, a huge component of your overall bill. So if you can spread that out over more people, that's huge in that sense. So I think consolidation is one of the elements that that's going to be a tool to help smaller agencies deal with the rising costs of water. And yeah, Max, do you want to add anything to that?
So the only thing I'm going to say that fixed cost point is important, and electricity is about to look more like water than it ever has, because when we think about renewables, right, solar, wind, most of it's fixed costs, and the variable costs are very small. So there's lots of interesting economics going on the energy side that now look much more like the water side than they do traditional sort of fossil generated energy.
All right, thanks to you both for the answer to that. So we have another question for Kurt. So in your conclusion, you said single pricing won't do the trick. Can you tell us more about it? Are you proposing a tiered pricing system to address affordability and equity issues?
Yeah, actually, that was a comment about budget-based rates. I like a lot of elements of budget-based rates, and but I think go back to again, I think I'm going to hold on to my environmental economics card here, the Tinbergen principle that for every target you need an objective or a tool, an instrument. And in this sense, to try to deal with efficiency and equity with one pricing instrument, even if it's a budget-based instrument that's going to be hamstrung by Proposition 218, which has these limitations on how you can charge for water based on the cost of water. And so in that sense, I think it's a heavy left. It's too much of a left for a single pricing instrument to deal with efficiency and equity. And this is where you need cooperation versus horizontally, across different agencies, electricity, water, essential services, food, security, housing, and you need cooperation vertically as well with the county and the state in addressing the affordability issue. Pricing and conservation is an important component of that, because the less water you use, right, the lower your costs. But you have to think about these other elements as well. And I think cooperation and coordination across vertically and horizontally is important. Smart investments is important. If improving water use efficiency is important. Kind of all of the above.
All right, awesome, thanks. Max, did you have anything to add to that?
No, I think that was great.
Okay, so if I'm not mistaken, I think that's all of the questions. So I think we'll go ahead and thank both Max and Kurt for joining us. And I think Tina has a few closing comments, and we also have a closing poll as well.
Yeah, thank you, Brittany. Thanks to both Max and Kurt for joining us today. We really appreciate it. I want to give a brief pitch for our next webinar, which will be November 2nd. We're going to be discussing the opportunities and challenges for California's agricultural labor market, thinking about COVID, H2A workforce, and mechanization. And so you can register for that on our website at arediscussions.ucdavis.edu. You should also be seeing a poll on your screen. We're trying to do a survey to get more information about our audience's perceptions of the webinar, and to be able to guide different topics and speakers in the future. So thank you so much, and we'll look forward to seeing you next time.